Hello, everyone. Thanks for attending today's webinar, an introduction to the latest generation general-purpose burstable instances. My name is Meena Gowder, and I'm a product manager with the Amazon EC2 team. Many general-purpose workloads don't need sustained fixed CPU resources all the time. Burstable instances help get you the compute resource your workload needs whenever and for as long as you need it, while still keeping your costs low. In today's webinar, we will take a closer look at EC2 T3 instances and how they are helping achieve better performance at lower prices for general-purpose workloads. So let's start by brushing up what are burstable instances. AWS offers a variety of instances to suit your needs, from storage optimized to memory optimized to GPU accelerated. The T family of instances are designed for applications with variable CPU usage that experience occasional spikes in demand, and you see them sitting in the far left side of the spectrum of general purpose instances. So, the burstable instances are an instance family from EC2 which provide a guaranteed level of CPU performance with the ability to burst to high levels of CPU utilization for transient or spiky loads. Now, each instance has a baseline CPU which is governed by what we call the CPU credits. CPU credits get used while the instance is active, and they accumulate when the instance is operating below the CPU baseline. Now let's look at the T3 instances. T3 is the newest generation general-purpose burstable instance family. It is a successor to T2 and was launched on August 21st this year. T3 offers roughly about 30% better price to performance over the previous generation T2 instances. They are powered by high-frequency Intel Xeon processor based on new Intel's microarchitecture called Skylake. So looking deeper at the technology powering T3, T3 is built on the new EC2 lightweight hypervisor called AWS Nitro system, which is a collection of AWS-built hardware offload and hardware protection components that come together to securely provide high-performance networking and storage resources to EC2 instances. You also get a minimum of 2 vCPUs on smaller instance sizes compared to T2. T2 instances are enabled by hyperthreading. Hyperthreading technology is Intel's proprietary simultaneous multithreading implementation used to improve parallelization of computation doing multiple tasks at once on the x86 microprocessors. So here, for each processor core that is physically present, the operating system addresses 2 virtual cores and shares the workload between them when possible. The main function of hyperthreading is to increase the number of independent instructions in the pipeline. So continuing on T3's enhancements. T3 instances have improved network performance, offering up to 5 gigabits per second bandwidth at burst when launched within an EC2 placement group and enabled with the Elastic Network Adapter or the ENA-based enhanced networking. T2 has 1 gigabits per second at burst, so you see the difference that you're getting here. T3 instances also offer higher EBS bandwidth across all instance sizes compared to T2. So T3 EBS burst bandwidth is more than 3 times compared to some of the T2 smaller sizes. So starting from the T2 Nano through the T2 Medium, you only got half a gigabits per second, but on the T3 you get up to 1.5 gigabits per second. And then on the larger sizes, T2 offered only 1 gigabits per second, but on the T3 larger sizes you get up to 2.3 gigabits per second. You also get burst IOPS up to 16 kilobytes. So T3 is optimized for EBS and will offer only EBS volumes. There's no local storage variant on T3. So what sizes do EC2 burstable instances come in? So here's a summary table of all the instance sizes offered for T3. the number of vCPUs and memory, along with EBS bandwidth and the network bandwidth at burst. And here's a look at the table of all the instance sizes offered for T3, the number of vCPU, memory, and baseline CPU, along with the max credits earned per instance size. Now you can see that for an example size T3 2 extra large, the instance can earn up to a maximum of 4,600 per day, and that's like the maximum. If an instance is idle the entire time and it earns the max credits, the instance has accumulated enough credits to burst at 100% CPU across all 8 vCPUs it has for a maximum of about 10 hours continuously without paying any extra credit. So when would I use an EC2 burstable instance? Burstable instances are used for most general-purpose applications that can benefit from quick access to high levels of CPU whenever needed, but most of the time are using moderate levels of CPU. Additionally, T2 and T3 burstable CPU instances are the only option for nano, micro, and small instance sizes, making them a good choice if you're running a smaller workload that doesn't need the capacity of larger instance type. T3 instances are also great to compare with their EC2 M5 equivalent, or M4, when your workload doesn't need fixed CPU all the time. The larger instance types, T3 large, extra large, and 2 extra large, mirror the memory allocation for the equivalent M instance types, but with limitations on the amount of CPU available for a sustained period. So however, with unlimited mode enabled, you can get the CPU your workload needs without having to pay a higher price all the time. The rule of thumb is that the average CPU utilization over time should be at a threshold such that the total price you'd pay for a T3 base instance plus any surplus credit will still be lower than if you ran the same workload on M5 equivalent size. So let's look at that with an example, how you would calculate this threshold. So here's an example that shows the breakdown of when it would make sense to use a T3 instance instead of M5 based on the average CPU utilization, your workload, and how much it is going to cost for you. If my average CPU on a T3 large instance is always less than 42.5% over any given period of time, for simplicity, we'll just use an hour calculation. The cost of running on T3 instance will be cheaper than running on M5. Let's work through this calculation. So M5 price is 9.6 cents per hour. T3 price is 8.35 cents per hour for the large size. So the price difference between them is 1.25 cents an hour. So if a T3 instance needs the use of a full vCPU, it is charged at a rate of 5 cents per vCPU hour. Or if you break it down to the minute level by dividing the 5 cents by 60, that gets you 0.08 of a cent per minute. So in order to see how much additional T3 usage we can have without going over an M5 price, we use this equation. It's like 1.25 cents price difference between T3 and M5 and divide that by the credit price per minute. That gives you 15 minutes of 100% burst performance you can get. Or if you stretch that out to 60 minutes, you get 12.5% of additional burst CPU over 60 minutes. So you actually can enjoy up to 42.5% average CPU utilization while still saving cost by running on T3. And you can play around with other sizes to see how much it would cost you if you burst on T3 all the time as compared to M5. I can tell you it will cost you roughly about 1.5 to 1.8 times as running on M5. If you think your workload will need fixed CPU all the time, then you're better off cost-wise to run your instance on M or C instance family. But if you're going to have an average workload utilization lower than 42.5% on a large size, T3 will save you a lot of money. So here are some sample workloads that benefit from the burstable nature of T instances and will be able to burst CPU whenever they need to for as long as they need to. T instances are not just for microservices or test environments. They work great for those, but T can also run in unlimited mode and can burst whenever and for as long as your workload needs it. T is also suitable for production workloads. So we see a lot of gaming servers, we see low latency interactive applications, virtual desktops have benefited from the low cost and better performance that you get from T3 instances. So how do burstable instances work? Traditional EC2 instance types provide fixed performance, while T instances provide a baseline level of CPU performance with the ability to burst above that baseline level. The baseline performance and ability to burst are governed by CPU credits. A CPU credit provides the performance of a full CPU core for 1 minute. Baseline performance is the CPU performance that the workload will get at the base price of an instance. When workloads run below baseline, the instance will earn CPU credits. The instance is always earning credits, but it also uses credits when consuming CPU. The number of earned CPU credits varies depending on the instance size. The earned CPU credits can be used by the workload to burst above baseline. So T3 instances can operate in two modes, standard and unlimited mode. An unlimited mode will be enabled by default on T3. However, on T2, the standard mode comes enabled by default. And then another key call out is that unlike T2, T3 instances will not offer launch credits. But since it's enabled with the unlimited mode by default, you can start bursting the instance right from the get-go without compromising on your experience. And for context, launch credits are free credits given to instances at start, as it has not yet earned credits for a good startup experience. That was applicable for T2s, but it no longer is a restriction on T3s. So you can burst right from the beginning. So let's look at how the T3 CPU credit mechanism works. Similar to T2, it's a token bucket model. Credits are earned at a rate based on baseline performance level of the instance size. The formula is the number of CPUs available on that instance multiplied by the baseline level, the percentage, multiplied by 60. That gives you the total CPU credits earned per instance size. So credits are consumed for CPU utilization. The maximum accumulation of the CPU credit balance is based on the instance size. Credits don't expire up to 7 days for stopped instances. They never expire for instances that are running, but will remain capped at the max number of credits per instance size because it's based on a bucket model. Credits expire when an instance is terminated, and then when credits are consumed, they are calculated at a per millisecond granularity. While earned credits never expire on a running instance, there's a limit to the number of earned credits an instance can accrue. So the limit is determined by the CPU credit balance limit. Once this limit is reached, which is the size of the bucket for the instance size, any new credits that are earned are discarded, indicating by this picture where the bucket is full, the CPU credit balance is reached, and the spillover indicates that any newly earned credits that's exceeding the limit will just not be part of that CPU credit balance. In the event an instance never exceeds baseline, max earned credit is capped per day and can continue to earn each day until the old credits expire after 7 days. When a T3 standard instance is in a running state, below baseline CPU utilization, it continuously earns, at a millisecond level resolution, a set rate of CPU credits per hour. So when a T3 standard instance is stopped, its accrued credit is saved up to 7 days. And unlike T2, the accrued credits where they are reset to 0. The number of accrued CPU credits is tracked by the CloudWatch metric called CPU credit balance. If the instance is running low on accrued CPU credits, performance is gradually lowered to the baseline performance level so that the instance does not experience a sharp performance drop-off when its accrued CPU credit balance is depleted. I'll demonstrate with an example of how a T3 Nano standard mode works. Say for a period P1 for the first 24 hours, the instance is idle at 0% CPU utilization for a 24-hour period. The max credit the T3 Nano instance can earn is 144. How do we calculate this max number of credits per instance type? Again, the formula is number of vCPUs per instance size multiplied by the baseline CPU percentage multiplied by 60 minutes per hour and then 24 hours per day. So you multiply all that, you get 144 CPU credits. That's the size of the bucket for max number of CPU credits this instance size can earn. Here's period 2, which is the next 12 hours. The instance is now running at 2.5% CPU. Technically, it is earning 6 credits per hour and spending 3 credits per hour when running at 2.5% CPU for the next 12 hours. But since the max credits have already reached at 144, the bucket is full and the credits don't accrue beyond that level, 144. So that's why you see that the graph kind of remains flat at 144. Now let's look at period 3, which is the next 24 hours. CPU is bursting a little bit above baseline at 7% for the next 24-hour period. We break down the 7% CPU to 5% baseline, which you get, and then the 2% that you are bursting above baseline. So the baseline 5% will earn and spend 6 credits per hour and get covered there. The incremental 2% CPU above the baseline will burst using the accrued CPU credits from the CPU credit balance. This will require roughly about 57.6 credits, which is calculated as 2% incremental CPU burst multiplied by 2 vCPUs times 60 minutes per hour and the 24 hours per day. So the balance credit now will lower down to 86.4 credit after it has consumed the 57.6 from the max it originally had at the beginning of the 24-hour period. Then we have another period of 12 hours where the CPU comes back to 2.5%. Here there's an opportunity for the Nano instance to earn more than it spends. It earns 6 per hour or 72 credits in the next 12 hours. It spends 3 per hour or 36 in the next 12 hours. So it will accrue the unspent 36 credits in the next 12 hours. So the new credit balance has started to go up, and it has gone up to 86, from 86.4 up to 122.4. So here comes a period, a short burst period, where the instance wants to burst at CPU, say 60%. And it can burst in this high CPU level as long as there are credits in the bucket. So the Nano instance can burst at 60% using all the 122 credits for roughly about the next 111 minutes, which is 1 hour, 51 minutes. How is this duration calculated? So 122 credits divided by 55%, which is the burst above the baseline, divided by 2 vCPUs gives you 111 minutes. So CPU credit balance goes down to 0 at the end of the 1 hour, 51 minutes, and then CPU bursting is throttled back to baseline slowly as you kind of run out of CPU credits. Then during period 6, which is for like the next 8 hours, the instance is chugging at baseline CPU of 5%. It earns 6 credits per hour. It spends 6 credits per hour. So nothing is left to accumulate in the CPU credit balance bucket. The credit balance remains at 0 here. And then once the instance goes back to an idle state and not using any CPU, it can start to earn 6 credits per hour and keep accruing into the credit bucket. And you see that over the next 24-hour period, the credits start to grow all the way to the max of 144 credits. And then from that point on, if the CPU continues to be idle, it will just stay flat at 144 credits for CPU credit balance. So it's just kind of like an example of how this will work in the standard mode. Now let's talk about the unlimited mode. If the same T3 Nano instance was running in unlimited mode, the instance can continue to burst after exhausting all its accrued credit balance by consuming what we call the surplus credits. Surplus credit is made up of surplus credit balance, which can reach up to a maximum of 144 credits in the case of the T3 Nano, and then a surplus credit charge will start to accumulate, which is the number of credits the instance will get charged beyond any potential credits it can earn in the next 24 hours. So why are we allowing this? It allows the instance to burst for as long as it needs to and pay down the consumed credits within 24 hours without being charged at all, as long as your average CPU utilization over a rolling 24-hour period is at or below baseline. But if your average CPU is above baseline, you just have to pay for those credits that you're using. So let's see how could this instance behave in the previous example if that instance was operating in unlimited mode. So here we'll start from period 5, which is for the duration of, say, 5 hours that the instance wants to burst at full CPU power. Let's break it down. The instance had 122 credits in its bucket. So it can use up its accrued credits at burst at 100% CPU, which is 95% above the baseline, and run for slightly over an hour. So it uses 114 credits are needed to burst at 95% above the baseline for the next hour. Then there will be like 8 credits that will take you slightly less than like 1 minute, after which the instance is out of credits. So in this stage, if the instance was operating in standard mode, it would be throttled and brought back to baseline. But since we are operating in unlimited mode, we allow the instance to continue to burst. This is when the surplus credit will start building and keep building until it hits 144, which is the potential number of credits the credit bucket can fill up in the future if the instance gets back to baseline. The 144 will get you roughly about an hour and 15 minutes. After this period, any additional surplus credits the instance bills is going to be billable surplus credits, or if you see the metric, it's called surplus credits charged, which we show here as the surplus credit charge here in the graph. So for remaining duration of the bursting period, the instance will require an additional 304 CPU credits to finish bursting in that 5-hour duration, or 114 per hour, bursting at 95% above baseline for the next 2 hours and 40 minutes. And then after that, you come down to like period 6, which is for roughly 8 hours. The instance is running at baseline CPU of 5%. The instance earns 6 credits per hour. It spends 6 credits per hour. So the surplus credit balance remains flat at the 144 credit limit. Nothing is coming back down. And you're not earning any credits either. And then during period 7, the instance goes back to idle, and it remains idle for the next 24-hour period. The instance is earning 6 credits per hour, and it's not using any CPU, so it just starts to accrue, and it pays back the surplus credit balance, and you see that surplus credit balance, the red line, starting to come down all the way to zero as you're earning credits and accruing them to pay back the surplus credits. So that's why when your average CPU utilization over a rolling 24-hour period is at or below baseline, you will not have to pay for any additional charges. However, here you did accrue in period 5, you did accrue a surplus credit charged of 304 credits, which will be charged at 5 cents per vCPU hour. So let's look at an example from CloudWatch. So here's an instance that has been running at 0% CPU utilization for several hours, and it started to accrue credits up to 34 credits over time. And then at this point, roughly at the 4th hour, the CPU, which is the green line here, started to ramp up, going all the way up to 100% here. As the CPU utilization started to go up, you can see that it started to use the CPU credit and the balance started to drop down. This is at an hour interval, so you'll see a little bit of disconnect. If you go to a smaller granularity of 5 minutes, you can see exactly how they match up. So the CPU starts to come down up to 0. And then after it comes down to 0, you'll see that the CPU surplus credit balance starts to go up while still allowing you to burst at a higher CPU utilization. And the balance goes all the way up to 144, close to 144. That's like the maximum number of credits you can earn. And it remains flat after that. So once the max number of surplus credit balance reaches the 144, here the red line, which is the surplus credits charged, starts to go up, all the way up to 114 per hour. That is the number of credits you need to burst per hour for the 95% above baseline. So every hour, the instance is using 113 CPU credits that are billable, and it will continue to use that for as long as the workload needs or until you switch it back to standard mode if you no longer want to burst in unlimited mode. So here, what happens is we switched the instance to from unlimited mode to standard mode. So the CPU utilization from 100% started to go down to close to 0. And when we switch the mode from unlimited to standard mode, immediately we charge the surplus credit billable at that point in time. So there's a total of 208 credits that get charged at that point in time. And then your surplus credit balance also starts to come down to 0 when the instance is switched to standard mode. Here are some alarms that can be set if you don't want to accrue too many billable CPU credits. You can set an alarm here, put in name and all that, and then you can define at what point you want an alarm. When the CPU surplus credit charge goes about, say, 200 or 144, you just don't want to pay too much. And like the first time this data set happens, you immediately want a notification to be sent to you. You can figure out how you want to send the state is an alarm. Here's a notification. You send like all the email addresses where you want the notification to go, and then you can create an alarm here. So that way you can control how many credits you want to pay as you go versus just sustain at surplus credit balance and not have to get charged for CPU credits. So I want to continue a little bit back on this theoretical slide where we kind of walk through a different time period. So in the CloudWatch dashboard, I showed you what happens to the CPU utilization and the CPU credit balance when you switch from unlimited mode to standard mode. So in addition to the CPU surplus balance coming down to 0, There's also an opportunity to start accruing credits after you switch back to standard mode and the instance is in idle. So here in period 7, the instance is switched to standard mode. It's no longer bursting. The workload doesn't need any baseline CPU. It's idle. So the surplus credit the surplus credit went down to 0, and then your CPU credit balance is starting to ramp up here. Okay, now let's look into how T3 instances are priced. So overall, T3 instances are 10% cheaper than T2. Windows price are calculated based on the number of vCPUs per instance and the baseline performance per instance size. So it necessarily won't show the 10% cheaper when you compare from T2 Windows Army to a T3 Windows instance type. That's because we give more performance and more number of vCPUs on the T3 instance. So depending on your cost constraints and how you want to use, you can choose between T2 versus T3. You definitely get more performance with T3 instances. CPU usage is tracked at microsecond granularity in vCPU hours, and it's billed at the end of the month at 5 cents per vCPU hour for Linux, Red Hat, and SUSE. And for Windows, it's 9.6 cents per vCPU hour for the Windows OS. Similar to T2, T3 has the same 5 cents per hour across all pricing models. So if you're using OD, RI, or Spot, the CPU credit price is 5 cents per vCPU hour. I want to make a couple of callouts here. One is regarding the launch credits. There are no launch credits in T3 instances. You don't need them to burst in unlimited mode. And since we have unlimited mode enabled by default, you will have a good startup experience. And if you don't want to use unlimited mode, you can go back to standard mode. But unfortunately, we're not supporting launch credits on T3 instances. And then another call out is regarding the Spot pricing. The surplus credit pricing on Spot is also same as OD, so it's 5 cents per vCPU hour. If you plan to run the instance as a Spot for a very short period of time, say less than an hour, and you burst CPU above baseline, T3 Unlimited may not be the instance I'd recommend. If the instance is turned off before it can earn any credit, you will be billed for the surplus CPU credits, and T3 can turn out to be more expensive than if you ran the same workload on an M or C instance on Spot. So you should use caution in picking the right instance type depending on how much CPU you're going to use for your workloads. Alternatively, you can use the T3 instance in standard mode while running on Spot. So think about it a bit before you use unlimited mode and just burst CPU. So let's look at where T3 instances are available. We currently have T3 in 12 different regions. In the US, we cover both East 1 and East 2 regions. In the West, both West 1 and West 2 regions, that is the Oregon and California. In Canada, we have Canada Central 1. South America, Sao Paulo, the AP Northeast 2 region. In Europe, we have support in Frankfurt, which is the EU Central 1, EU West 1, Ireland, and EU West 2, London region. In Asia, we currently support AP Northeast 1, which is Tokyo, and AP Southeast 1, that is Singapore. In Australia, AP Southeast 2, Sydney is also covered. We will be expanding to bring T3 in other regions as well soon, so keep watching out for additional launch news that comes out. So how do you switch your existing T2 instances to T3 instances? So T3 instances have few prerequisites that must be met before a T2 instance can be switched to T3. First, it must have NVMe drivers installed in the ARMY. T3 instances use NVMe interface. NVMe uses a different device name scheme. If device names are used for file system mounting, they will need to be modified to change the device names or use device IDs, which we recommend. Next, it must have the Elastic Network Adapter or the ENA drivers installed. Similar to C5 and M5 families, T3 instances use enhanced networking that's based on ENA. So your ARMYs need to be ENA enabled. There's a ton of documentation about how to check if ENA is enabled on your instance and how to enable it. You can find it from the AWS EC2 user guide. Also, you cannot use Classic Link to enable communication between an EC2 Classic instance and a T3 instance. There's more documentation about that, the support for Classic Link limitations. So please have a look at our user guide to get more information on that. Quickly, let's look at the supported ARMYs on T3. Here's a list of all the ARMYs version and the supported version and all the future versions from here will be able to run T3 instances. I also want to call out that EBS-backed HVM ARMYs with support for ENA networking and booting from NVMe storage can be used with T3 instances. Customers will not be able to launch a T3 instance if they try using an ARMY that is not supported. If they select an ARMY without ENA, then the T3 instance would be grayed out on the console, or you'll get an error message in the CLI if you provide like the incorrect ARMY ID while trying to launch T3 instance. Also, no PV and S3 backed ARMYs will be supported on T3. So as I also want to call out that as your needs change, you might find that your instance CPU is underutilized. If this is the case, you can change your instance type, say from an M4 or M5 to a T3 instance. If the root device of your instance is an EBS volume, you can change the size of the instance simply by changing its instance type, which is known as resizing it. So if the root device for your instance is an instance store volume, you must migrate your application to a new instance with the instance type that you need. When you resize an instance, you must select an instance type that is compatible with the configuration of the instance. If the instance type that you want is not compatible with the instance configuration you have, then you must migrate your application to a new instance with the instance type that you need. Okay, so let's do a demo here, switching an M5 instance to T3. I'm going to walk you through how you can select your EC2 instances from the console and then switch them to, say, from an M4 or M5 to a T3 instance, and you can kind of take a look at it. So here's my console with few instances that I'm running. I'm going to pick an M4 large instance that I'm going to resize to a T3. I'll start by selecting that instance and going to Action, look at the instance state. I'll have to first stop the instance. So once I say yes and stop, it will take a few minutes for the instance to stop. And once it's done stopping, I can choose my instance that I want to resize it to. So now my instance has stopped, and so I still have that chosen. And I am going to say change instance type, and I can go pick whatever instance I want to resize it to. Here I'm going to move it to a T3 large. And since T3 instances are optimized for EBS support only, it's selected by default. You don't have a choice to deselect it. and then you apply, and now it has been resized. You see it looks as T3 large. Now if I go and start my instance, it will start as a T3 large, and you will also see so here you see once the instance has started to run, it now launches in unlimited mode enabled by default. So you do have a choice to go disable it. I will show you how to do that. You take the same instance, you go to Actions, go to Settings, here you go. And then you say change T2, T3 unlimited. For this, you go say disable, and then once you disable, you can see that the unlimited mode has been disabled. So now it's just running in standard mode. So you can do that from console, and you can also do this by selecting bulk edit, select multiple instances, and do the same thing. You can go change them to unlimited mode, you enable, you disable, you can do that. But when you do a bulk edit, you can only do one function together for all of them. So just keep that in mind that you're doing a bulk edit versus a single edit. So I also wanted to share some commands on how to switch between T3 modes from the CLI. So if you want to fire up a T3 instance of a particular size from command line and specify it to be standard, here you just say CPU credit attribute to be standard or unlimited, and then the instance will launch in standard or unlimited mode. You can also pick an instance that is already running right now and modify it from one mode to another. Same way, you kind of specify the CPU credit as unlimited right here, or you can specify it as standard, and that will switch the instance to your preferred mode. Now, if you are wondering what size your instance is running in, what mode your instance is running in, you call the describe API, and you give the instance ID here. This is like a dummy instance ID. You're not going to have a sequential number like this. When you do that, you will get the response to be whether it's running in unlimited or standard. So if it's standard, you'll get standard CPU credits here. If it's running in unlimited mode, it will give back unlimited. These are some of the metrics we saw on the CloudWatch dashboard when I walked you through the instance. So I just wanted to kind of bring it up here and explain what each of these metrics mean, and what are all the CPU related credit metric you have on the CloudWatch metric. You also have a ton of other metric related to network, EBS read-write, all of that you can get details about how your instance is utilizing your network bandwidth and EBS bandwidth from CloudWatch, along with setting up alarms there. So some quick FAQs that frequently get asked is switching between the modes, standard and unlimited supported, yes. Earned credits are carried over. Surplus credits are immediately charged when you switch from unlimited mode to standard mode. So just gonna keep that in mind when you switch the instance, but you will be able to switch between two modes from T2 and T3. Also, your earned credits will get carried over if you switch from T2 to T3 or T3 to T2. Does autoscaling group support T3 unlimited? Yes, this is supported via the new launch templates and the one-click launch configuration to launch template conversion. So this is kind of like a new feature enhancement that was rolled out to support with autoscaling group. Unlimited mode is available through launch templates, not through launch configuration, but you can migrate your launch configuration to launch templates through like this one-click feature. Does CloudFormation support T3 Unlimited? Yes, this is also supported using the launch templates, and native integration is coming soon, so you should be able to use that. Do Elastic, Beanstalk, and OpsWorks support T3 Unlimited? Not yet. This work is being planned, and we should be rolling this out soon, later this year. So I want to do a quick recap of T3 instances. So T3 instances are 10% cheaper than T2 on Linux across OD and RI price. It is 13% cheaper than M4s. You get 30% better price to performance than T2. You get burst performance that is just as same as M5. If you need to burst 100% on T3s, you can perform just like an M5. T3s is available as OD, 1-year RI standard, 1-year convertible, 3-year standard and convertible, and also on spot pricing. So that wraps up our presentation today. Thank you for joining me.